Welcome to a lesson with Dr. Powell. Let's try to use the ratio test on this series and see what happens. Now remember, our setup is something like an plus 1 times 1 over an. So we're going to take the reciprocal of this. Now we're also going to focus on absolute values because this test only focuses on absolute convergence. So if we take the reciprocal, it's just square root of n plus 1. Multiply that by as because we're just focusing on absolute values. Then we take an plus 1, so we just replace n with n plus 1, so that'll look like 1 over square root of n plus 2, right? And now we're set up to take a limit. Now as we take a limit, this is really like the limit of n plus 1 over n plus 2. And the limit can come inside. Limit of this part right here is just 1. So it looks like the limit of the whole thing is 1. Oh, the ratio test is inconclusive. We cannot use it. So we have to default to another test. Now, a favorite common other test that we can use if the ratio test does not apply is the alternating series test, or perhaps an integral test or a p-test. So if ratio test fails, okay, so ratio fails, then we either go to alternating, if we can. In this case, we can because we have a negative 1 to the n. But if we can't, then we go to so an integral test, or like a p-test, or an integral comparison, or a series comparison. So we compare it to another series where we can take an integral. So we compare it to a series that we can integrate and use the integral test or the p-test on even, and then we're good. So so right here, well, you know what, if we, but these tests, remember right here, these are actually absolute tests. This one is a conditional test, conditional convergence. These are absolute value tests. Now, if you took the absolute value of this looks like 1 over n squared of n plus 1, which is related to like 1 over square root of n, which diverges off that way. So actually, it looks like the absolute values really do diverge here just by that test. However, it is alternating, so we should take advantage of that and see if we can get conditional convergence out of this. We know we won't have an absolute convergence by that comparison note, but we still could get this. So we know it's alternating. Then to test for convergence, we just need to know that the absolute values of the terms are decreasing. Now this is a decreasing function because it's just a shift of a shift to the left even of a decreasing function, 1 over root n. Looks like this anyhow. You could take a derivative if you want to of that to see, because this is n plus 1 to the negative 1. And you take a derivative with the chain rule, it's like negative n plus 1 to negative 2. That's negative. Yes, it's decreasing. It's negative. So it's decreasing. Does it limit to 0? If you take a limit this, do the terms go to 0? As n approaches infinity, you get the denominator going to infinity, so we get 1 over something big, which goes to 0. So yes, we get that it's decreasing, the terms go to 0, and it's alternating, so therefore we actually do get that this series converges conditionally. Through all that rigmarole, we tried the ratio test failed. We can go here to compare with an integral test or something, or a p-test, and we can see that it actually absolutely diverges. However, does it conditionally converge? That's when we go to this test. This is the one test that we really have for conditional convergence right now at the moment, other than just finding a formula for the nth partial sum and taking a limit. So really, conditional convergence, we only have 2 ways of doing it. Formula for the formula for the nth partial for a partial sum and take a limit of that formula, or use the alternating series test. there may be other various ways, but those are the two that we have established that we are using for conditional convergence. But we also see right here at this that this absolutely will fail to converge. But we did not see that by the ratio test. The ratio test failed. The ratio test didn't tell us anything. Just yeah, if it outputs one, we don't know anything. So then that's why we have to go to these two tests. So these are these variants of tests. These are the tests that actually told us something. This one told us that it absolutely does not converge, or doesn't converge absolutely. And this one tells us that it converges conditionally. Thanks for watching.